What is up, amigos? Society has told potatoes that you can't be anything other than chips, or jacket potatoes, or French fries. But this potato doesn't want to be those things. This potato wants to be more than that. It wants to be supersonic. This potato wants to be great. This potato is Paulie. And here is Paulie going supersonic. We have a white line going through, and you can see the blue is subsonic flow, the red and orange is supersonic flow. And at the front, we can see this massive blue bit, which is pretty much where all this drag is coming from. You have all this air being crunched together, and it can't get out of the way, so you form this like pressure barrier. And the drag on the potato is quite a lot. It's on Paulie, I should say. It's 4.86, the drag coefficient, which is about twice as much as the carrot that we saw last week. But considering how blunt Paulie is, it's not surprising. Another thing that's interesting to note is the blue bit at the back is going down at an angle. And if you've seen any of our other videos, you know that that indicates that we are producing lift. And this is actually true. So Paulie has a lift coefficient of 0.3, which is pretty good. It's like kind of wing-esque. And that makes sense because if you look at the top of Paulie, he's rounded, and at the bottom, he's fairly flat. So that's effectively like an airfoil profile. You see the shock pattern as well is this diamond pattern coming off in the yellow at the back. And we have the temperature plotted here in that exact same plane. And we have the purple is high temperature, red is low temperature. And the maximum we see here is about 340 degrees Kelvin, which is just not enough for the potato to cook, which is a good thing for Paulie, I guess. You need to get up to about 373 degrees Kelvin, so we're about 30 degrees short. In the Werq though, we also get quite a high temperature over the top. The temperature gets quite low to a chilly 240 degrees Kelvin, which is below freezing. This is the same plane, but with a pressure plotted now. We can see just how much pressure there was upstream. We have this massive high pressure zone, and then below there's not much, at the back there's not much pressure, so that has that pressure difference, which results in that high drag coefficient that we saw. We have a Z-plane now going from bottom to top, and we see the blue part here is the subsonic part, and then the red part is the supersonic part. And Paulie is a little bit asymmetrical, which means that the shock wave coming off of the top part of our screen is different to the bottom part of the screen. It's at a slightly different angle and slightly different intensity. You can see it's significantly faster moving flow on the top part of our screen than the bottom part of our screen. And this plane is the exact same one, but with the pressure. And we can now see that there are a few different low pressure zones. We see the major low pressure zones, which comes from the shock, but also just in front of that, we get slight, small low pressure zones. And that's because of the geometry of Paulie. You can see that the geometry kind of like fans out a little bit, then juts back in, then fans out again. Those bits that jut out, they create this low pressure zone. And then we get the high pressure at the front of Paulie and low pressure at the back, which results in that high drag that we saw. And this is a really cool plane. This is an X plane going straight through Paulie. And it's cool because we see the Mach number, and at the very start, there was this massive blue like circle around it. That's all that very like condensed air that's resisting Paulie breaking the sound barrier. That's what's holding Paulie back. Not only society, but air is trying to do it too. But Paulie says, no, thank you. I'm going faster than the speed of sound. And that's what it's doing right here. So that's the end of the video. If you liked it, make sure to like it. And if you want to see more like this, check out our playlist and subscribe. And if you want to get better at CFD like this and or theory, check out our courses in link in the description. And I'll see you next video. Peace out, amigos.